everyone, thank you for checking out this video. You are with Coach Deathbot from 32 Academy.
Okay, moving on. Question 6. Given that in the expansion of 2 plus 3x to the power of n, the coefficients of the term that has x to the power of 3 and x to the power of 4 are in the ratio of 8 to 15. The question asks, what is the value of n? Right, with this constraint, what would be the value of n? Okay, let's try. So here, obviously in the expansion of this expression, binomial theorem would need to be used, right? So by the binomial theorem or binomial term, okay, theorem, let's say, the terms containing x to the power of 3 would need to be, right, this, which means that the second term need to be raised to the power of 3. So binomial theorem would mean that n choose 3 multiplied by 3x to the power of 3 times 2 to the power of n minus 3. Okay. Similarly, if you want a term that has the x to the power of 4, that means n choose 4, 3x raised to the power of 4, meaning that the first term, 2, will need to be raised to the power of n minus 4. Okay. And then now use the constraint from the question. The question said that the ratio from here to here is 8 to 15. Okay, so yep, and choose 3. Let me just rewrite that. Multiplied by, okay, I do not need to write x anymore because I only need the coefficient, right? So 3 to the power of 3 times 2 to the power of n minus 3 over, and choose 4 multiplied again. I do not want x to the power of 4 anymore. I only need the coefficient. So 3 to the power of 4 times 2 times raised to the power of n minus 4. The question said the ratio is 8 to 15. Okay, n choose 3 is n minus 1, n minus 2 over 3 factorial, right, which is 6. Okay, probably let's cancel the power 3 first. 3 to the power 3 will be gone, and the denominator will still have another 3. And the numerator n minus 3 is 1 more than n minus 4, alright? So that means that there will be 2 on top and 3 below. Okay, and choose 4, that is n minus 1, n minus 2, n minus 3 over 4 factorial, which is 24. Okay, is equal to 8 over 15. Okay, let me write in front here since I don't have much space. You notice that n multiplied by n minus 1 multiplied by n minus 2 have both at the numerator and denominator, right? So you can cancel that thing out. Okay? So after you simplify, you should get 8 over 3. Okay, this is not hard to see. N minus 3 still have left, equal to 8 over 15 on the right hand side. Well, that means that 3 n minus 3 multiplied by n minus 3 is equal to 15. That means that this is equal to 5. That means that n is equal to 8. So the value of n is equal to 8. Okay, moving on. Question 7. Let n be an integer and let triangle ABC is a right triangle with the right angle, the 90 degree is at point C. Okay, it is given that sine A and sine B are the roots of this quadratic equation. So the quadratic equation has the variable x, and n is basically a parameter. Okay, the question asks what is the value of this parameter n. Okay, it looks complicated, but how to try to solve this? Okay, let's try. So first thing first, sine A and sine B are the roots of this quadratic equation. Okay? So that means that I am able to write the sum of the roots and the product of the roots, right? So sum of the root will be negative b over a. So negative, that will be just this over a, which is the coefficient in front of x squared. Alright, product will be c over a. So c is 120, and a, which is the coefficient of x squared. Okay, but notice ABC is not just any triangle, right? It is a right triangle at point C. So angle A and angle B, there is an extra relationship to A and B here, which means angle A plus angle B is 90 degree. And if A and B, the sum is 90 degree, that means that, okay, A plus B is 90 degree. That means that cosine A is technically equal to sine B. So I can replace sine B with cosine A. Okay, so that will imply that sine A plus cosine A. So now I consider all the angle in terms just angle A. It will be this, and of course sine A cosine A with this. What else? Sine A and cosine A, right? Because I know that if I square it, right? Basically, if I square on both sides here, sine square A plus cosine square A, that will be 1 plus twice of sine A plus cosine. Not just write this. Basically, when I square it, this is also square, correct? And when I square the sine square A plus cosine square A, that would be 1 plus twice of the product of sine A cosine A. I would use this. Okay? So 2 times 120 over 5n plus 8 is equal to 7n minus 20 over 5n plus 8 square. Notice that here, when you square on both numerator and denominator and then you cross multiply, at the end of the day, it will still be just a quadratic equation. Okay, and let me skip this tedious work. I believe you all can do this. At the end, this quadratic equation will become n squared minus 65n minus 66. Okay, this can be easily factorized into n minus 65 and 66 and n plus 1. Okay, so meaning that the value of n is either 66 or n is negative 1. But notice that n is negative 1 may not work. Okay, because n is negative 1 would implies that sine A plus cosine A will equal to here, right, 7 times n, so 7 minus 1 minus 20 divided by 5n, so 5 negative 1 plus 8, and this give you a negative 9. But because A is a cube, right, A is an angle inside a right triangle, so if A is a cube, meaning that sine A plus cosine A will not be a negative value, right? It will be positive value. Okay, because A is in the first quadrant. Okay, so this is obviously false, right? So contradiction here. So that means that n cannot be negative 1. So hence, the value that only works is n is need to be equal to 66. It's the only answer. Next, question 8. The question says that find the number of integers x which satisfy this equation. Okay, So another way of asking would be solve this equation whereby x is only an integer. Okay, let's try. So if x is an integer, the base is an integer, right? Then the power is also an integer. Okay, so an integer raised to a power of an integer is equal to 1. Okay, so notice that if a and b are integer such that a power b is equal to 1, when is this possible? Okay, it must fall into either one of these three cases. Case 1 is the power need to be 0, right? So if the power is 0, whatever the base is, it need to be equal to 1, except when the base is equal to 0, right? So I need a to be not equal to 0, because 0 to the power of 0 is undefined. Okay, so that's the first case. Let's consider the first case first. Okay, so b is equal to 0, right? Meaning that is the power. So what it means is x plus 5 is equal to 0, x is equal to 5, negative 5, sorry. So I need to check whether it makes the base 0 or not. And you can check x squared minus 5x plus 5. When x is equal to negative 5, this is equal to 55, not 0. So meaning that, well, I can take this as one of the roots. Okay, so it's possible. Okay, so this is in fact possible. Just take it first. Okay, second case. What else that can equal to 1? Like a raised to the power b is equal to 1. What is the other condition? As long as the base is 1, right? If a is 1, if the base is 1, whatever the power is, 1 raised to the power of whatever will equal to 1. Okay. So that means that x squared minus 5x plus 5 is equal to 1. So x squared minus 5x plus 4 is equal to 0. Quadratic equation, and this can easily be factorized into x minus 1, x minus 4. Okay, so meaning that x is either 1 or 4. Right, so I have one more solution and one more solution here. Okay, the last case, which is the third case, what else? Okay, most of the students will forget this case. The base can be negative 1 as long as the power is even. Okay, so negative 1 raised to an even power will still give you the result of 1. So if a is negative 1, meaning that x squared minus 5x plus 5 is negative 1. So x squared minus 5x plus 6 is 0. Can be factorized into x minus 2, x minus 3. So here we would say x is either 2 or x is 3. Okay, I need to check. I need to make sure that the power need to be an even number, right? What is the power again? The power is x plus 5, right? So x plus 5 here is 7, x plus 5 here is 8. This is odd, right? So you need to reject. Okay, so here is even, so you accept, meaning that x is equal to 3. You can take as another root. Okay, so far we have x negative 5, x is 1, x is 4, and x is 3. So in summary, hence there are 4 solutions, okay, to this equation. So the final answer is 4. Next, question 9 is a geometry question. So ABC is an isosceles triangle with AB is equal to AC. D and E are points on AB and AC respectively. You can refer to the diagram, okay, such that the length of AD is equal to CE. as well as DE also need to equal to BC. Okay, it's already annotated in the diagram. Suppose that the angle AED is 18 degrees. So this angle is 18 degrees. Alright. The question asks what is the angle BDE in degrees. Okay, let's try. So first I construct an extra point F. So F is constructed in such a way that B, C, E, F is a parallelogram. Okay, so let's draw B, C, E, F. Right, so something like this. So this will be point F. Okay, then I just connect after D. So this is what I get. Okay, this is F. Alright. Okay, so because point C is an acute angle, so F for sure need to be outside of the triangle. Okay, notice that FB need to equal to EC, right? Because it's a parallelogram. Okay, and of course this is also 2 dashes. Okay, if you try to compare the triangle, right? So first thing first, I would have BF is equal to CE, which then equal to AD. Okay, what else do I have? BD, okay, this is equal to AE. Reason being is basically, let me just write here now. BD is equal to AB minus AD, and AE is equal to AC minus CE. But these two is the same, right? Because it's isosceles. These two is the same because the question said so. So meaning that BD is equal to AE. And of course, finally, angle FBD, okay, this angle, sorry, is equal to this, right? Because these two lines are parallel, right? These two lines are parallel. It's not drawn to scale, okay? So it's alternate angle basically. Okay? It's equal to DAE, alternate angles. So two sides, one angle in between. Okay, I would say that triangle FBD is congruent to triangle DAE. Okay, so this would imply that FD would equal to D. Okay, so this is actually also 2 dashes. And as we can see, all of these are equal. So equal to DE, that means that is equal to EF, right? So triangle DEF, all the 3 sides are equal. So triangle DEF is equilateral. Okay. Another implication from the congruent triangle is this angle should also be equal to 18 degrees. Okay. So here technically we can already answer the question. The question asks you to find the angle BDE. So BDE that would be FDE minus FDB. The triangle is equilateral, so this is 60 degrees and this is 18, and the final answer will be 42 degrees. Okay, last but not least, question 10. Find the number of ordered triples of real numbers. This should be triples, okay? X, Y, Z such that it satisfies the following system of equation. So x squared is equal to 4y minus 4, y squared is equal to 4z minus 4, and the last equation is z squared is equal to 4x minus 4. So how to solve this? Okay. So let's try. This is in fact actually is a pretty easy question. Notice that if you sum all the three equations together, summing the three equations together, and then so you would have x squared plus y squared plus z squared. You can rearrange this. You will get 4x, 4y, and 4z minus 12. And then you put everything on the left hand side. Okay. So x squared minus 4x, 12, right? I can break it into 4, and then again I can break it into 4, and here negative 4z, I can break it into 4, and the right hand side is just 0. Okay. Reason being of doing this, so now x squared minus 4x plus 4 is x minus 2 squared. This can write the same thing, y minus 2 squared and z minus 2 squared is equal to 0. So the sum of three squares is equal to 0. Each of these is non-negative, right? It's greater than or equal to 0. But the sum of all of this add together is equal to 0. So why would it be possible? It's only possible when each of these is equal to 0, right? So that means that hence the only solution, okay, the only solution is x, y, z respectively will be just 2, 2, and 2. So to answer the question asks how many triples are there, and there is exactly one triple, okay, which is 2, 2, 2. So the answer will be 1.
We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye, and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.